Module 3, Lesson 19, Problem Solving and the Coordinate Plane. Continuing to work on solving real-world and mathematical problems using the coordinate plane and using coordinates and absolute value to find the distance between points on the coordinate plane. For this particular lesson, I can solve problems finding the distance between points that lie on the same horizontal or vertical line. So straight out of Lesson 18. I can use the coordinate plane to graph points, line segments, and geometric shapes in the various quadrants, and then use the absolute value to find the related distances. So we're going to graph them and then use absolute value to measure. In the coordinate plane, find the distance between the points using absolute values. So we've got 2 points here. How far apart are they? Well, first I need to find the coordinates. 1, 2, 3, 4. So they're both at 4. They share an x-coordinate, which means that I have a vertical line connecting them. One of them is 1, 2, 3, 4, 5 units above 0, and one of them is 1, 2, 3 units below 0. So I have a vertical line that is 4 units to the right of the y-axis. I have distances from the x-axis. One of them is a distance of 5 from the x-axis. One of them is a distance of 3 from the x-axis. They are on opposite sides of the x-axis. I know that because one of them is a positive number and one of them is a negative number, so they're on opposite sides of the x-axis there. So I can add them together to find that they are 8 units apart. 8 units from each other. All right, exercise 1. We are going to locate and label 4, 5 and 4, -3. We are going to draw the line segment between the endpoints on the coordinate plane, and we are going to determine how long is the line segment. All right, so I've got 4, 1, 2, 3, 4, and 5, 1, 2, 3, 4, 5. And I've got 4 and -3. Now I noticed right away that they share this first coordinate, which means that they share a vertical line together. So I'm not surprised when I draw the line that connects them that I have a vertical line, because I had already predicted that was going to happen. Now, the length of the line segment, I've got a couple of things I can do. First, I could just count the units. 1, 2, 3, 4, 5, 6, 7, 8, and say that they are 8 units apart. Or I could use what we worked on in the last lesson, and I could say it's a vertical line going through 4. One of them is 5 units from the x-axis. The other is -3 from the x-axis, which means that we are 5 and 3, and I will add them together to find that they are 8 units from each other. So the same answer, one of them just counting the units, the other using our knowledge of absolute value. All right, we are going to draw a horizontal line segment starting at 4, -3. So I need to go to 4, -3. 1, 2, 3, 4. All right, I'm at 4, -3. If I want it to be a horizontal line segment, I've got 4, -3. For a horizontal line segment, a line segment that moves side to side, I know that the coordinate of my second point is going to be -3 because I want this horizontal line segment. Now I need a length of 9 units. So if I want to look at the length, I need to look at not these second coordinates, because that's what tells me I have a horizontal line, but I need to look at these first coordinates, the x-coordinate, and I need to have a distance of 9 apart. Now, one way that I could do this would be to just take 4 and add 9 more. 4 and add 9 more and be at 13, and then it would be a difference of 9. To go from 4 to 13 is a difference of 9. That's one way I could do it. So I would be at 13, negative 3. So somewhere clear off the side of the board out here is where I would be. That's one way I could do it. But that's not the only way that I can go 9 units from the 4. I could go the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm 9 units, but instead of going to the right, I'm going to the left. If that were the case, instead of having 13 comma negative 3, what would I have? Well, I had an absolute value of 4, and I needed 5 more. So I had the absolute value of 4, and I needed to get to 9. So 4 plus some number is going to get me to 9 units. And I need the absolute value of that number to be 5. Well, the absolute value of negative 5 is going to work for me. I've got 4 units here. I've got 5 units here. Altogether, a distance of 9 units. So pause for a moment, and I've already done this out loud. Which point did you choose to be the other endpoint of the horizontal line segment? To explain how and why you chose that point, locate and label the point on the coordinate grid. So I've already done that. Make sure you stop and you do some explaining for what you did and why. All right, exercise 3. The 2 line segments you have just drawn could be seen as 2 sides of a rectangle. Given this, the endpoints of the 2 line segments would be 3 of the vertices of this rectangle. So I'm going to put these points back on here. So I had 4, 5. 1, 2, 3, 4, 5. Oh, 4. 1, 2, 3, 4, 5. So I had this point right here, and I had 4, negative 3. And then I was over at negative 5. There we go. Negative 5, negative 3. So this could be 2 sides of a rectangle. And the question is, where is the 4th vertex, the 4th point? Now explain how you could find the coordinates of the 4th vortex using absolute value. Vertex using absolute value. Well, I know that my vertex right here is at negative 5, negative 3. And I know that I need to make a vertical line. So for it to be a vertical line, I know that I'm going to share the x-coordinate. So the question is, what is my y-coordinate going to be? Well, I know that I am 3 away from 0, so I'm going to take the absolute value of my negative 3. And I know that I need to reach 1, 2, 3, 4, 5 more. The absolute value of 5. So I've got 3 plus 5 for a total length of 8, and I'm going to be at negative 5, 5. And that's going to create for me a lovely little rectangle. So how does the fourth vertex that you found relate to each of the other consecutive vertices in either direction? So how does it relate to this vertice and this vertice? Which is a fantastic question. Well, it shares the same first coordinate as -5, -3, so it's sharing the first coordinate here. So I had -5, -3, and this is at -5 and 5, so they're sharing the same x coordinate, and it's sharing the same y coordinate, -5, 5, and 4, 5, and it's sharing the same y coordinate. So amazing little things that I can see by observing, by opening my eyes. I've already drawn the remaining sides of the rectangle. So we now need to find the perimeter of the rectangle. So I need to find the length. Oop. Come back here. There we go. All right. So I need to find some lengths so that I can find the perimeter. Remember, the perimeter is the distance around the outside of the rectangle. So if I can find the distance between this point and this point, and this point and this point, I should be able to find the whole perimeter. Because the perimeter is 2 times the length plus 2 times the width. So this side here is the same length as this side, so I can find one of them and double it. And this side here is the same as this side here, so I can find one of those two and double it and combine them together. So I've got my -5, 5, and my -5, -3. And if I can find their distance, see, this is a vertical line. I've got the absolute value of 5 and -3, which is 3. That side is 8. The two sides together, so if this is 8, this is 8. So I have a 16 there. I can do the same thing here, and by the way, this ties in with that question about the relationship of those consecutive sides. I had -5 and 5, and I had 4 and 5. So now I have -5 and 5. That's a horizontal line that is being connected. I can use the absolute values here to find the distance, 5 plus 4, which is 9, and I can double it to have 18. 9 and 9. If I add 16 and 18 together, I find out that I have a perimeter of 34 units. So finding the area of the rectangle, which of course I just went and erased. I know, very useful, right? So I guess I better put it back on here. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, we've got 5, -5, 5, -5, 3. I think I'm close. Yep, there we go. All right, so my rectangle's back. Now, finding the area. The area of a rectangle is the length multiplied by the width. So I have already figured out that this had a length of 8 and this had a length of 9. To find the area, I just do length times width and find out 72 square units. Now we're going to draw a diagonal line segment through the rectangle with opposite vertices for endpoints. So a diagonal line here. Now my rectangle has now been split, and I have made two new shapes called triangles. And the question is, what is the area of those triangles? Well, these triangles are half of the rectangle. so they're half of the length times the width. So half of 72 is 36 square units. All right, so here is an extension problem. I'm not going to cover that in this video. This might be something that would be fun for you to try on your own. All right, here we go. Exercise 7. Construct a rectangle on the coordinate plane that satisfies each of the criteria listed below. Identify the coordinate of each of its vertices. So we're making a rectangle, and I have to make sure all three of these things happen. Each of the vertices lies in a different quadrant. Okay. Its sides are either vertical or horizontal. Okay, so no diagonals. And the perimeter of the rectangle is 28 units. Okay, 28 units. So I have to make sure that when I add up the total length of the sides, that I'm going to have 28 units. Now, I was just showing you a few minutes ago that the perimeter is 2 times the length plus 2 times the width. I wonder if I could use that to help me with this problem. Pause and think about that for a second. Could that help us solve this problem? So I could pick a number for the length. How about 10? 2 times 10 is 20. And if I take 28 and subtract the 20, that means that my 2 times the width has to be 8. And half of 8 is 4. So I need line segments of 10 and line segments of 4. Another way to think of it is because I've got this doubling thing going on, is I could find half of 28 is 14, and I could say I need 2 numbers to add up to be 14. So I could do 8 plus 6. So I need 2 of the sides to be 8s and 2 of the sides to be 6s. All right, well, I can pick a point here, and I can go 1, 2, 3, 4, 5, 6. All right, there's a side that's 6. The other side needs to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And then here we go. Let's see how I did here. So 1, 2, 3, 4, 5, 6, which means this side is 6. 1, 2, 3, 4, 5, 6, 7, 8 means this side is 8 and this side is 8. 8 plus 8 is 16. 16 plus 12, 6 plus 6 is 12, is 28. Cool. So I have a vertice each in a different quadrant. I have a perimeter that is 28 units. I have sides that are vertical or horizontal, and I need to write down my coordinates. So let's see, this is negative 4, 3, and this is 4, 3, and this is 4, negative 3, and this is negative 4, negative 3. Now mine happened to turn out really nice that it's all using the 4 3s. Didn't have to turn out that way, it just happened that I randomly off the top of my head picked those numbers. Which is quite a coincidence because I really didn't plan that. Okay, using absolute value, show how the lengths of the sides of your rectangle provide a perimeter of 28 units. And of course, I just did it again. I just deleted, so I'm going to put them back here. All right. So I've got negative 4, 3, 4, 3, 4, negative 3, negative 4, negative 3. Okay, absolute values. So I need to find the length of this side. Negative 4, 3, and negative 4, negative 3. They share an x-coordinate, so they are a vertical line. They are opposite signs, so they're across the axis, so I can take the absolute value 3 plus the absolute value of negative 3, which is 3, and find out that this is 6, and because it's a rectangle, this side is 6. I've got negative 4, 3, and I've got 4, 3. These are the same, which means I have a horizontal line. These are opposite signs, negative and positive, so they're across an axis, so I can take the absolute value of negative 4, which is 4, and add it to the absolute value of 4, which is 4, which gives me a length of 8, and because it is a rectangle, the other side is also a length of 8. And 8 plus 8 plus 6 plus 6 is 28. All right. So how do we determine the length of a horizontal line segment whose endpoints lie in different quadrants of the coordinate plane? We use the absolute value. If they're in different quadrants, then the x-coordinates will lie on opposite sides of 0, and the distance between the x-coordinates can be found by adding the absolute values of the x-coordinates. The y-coordinates are the same and show that the point lies on a horizontal line. If we know one endpoint of a vertical line segment and the length of the line segment, how do we find the other endpoint of the line segment? Is the process the same with the horizontal line segment? So if the line segment is vertical, then the other endpoint could be above or below the given endpoint. If we know the length of the line segment, then we can count up or down from the given endpoint to find the other endpoint. We can check our answer using the absolute values of the y-coordinates. The process is similar with the horizontal line. If we know the length of the first line segment, we can count to the left or the right to find the other endpoint. And you'll remember we did a problem where I counted to get there. The length of a line segment on the coordinate plane can be determined by finding the distance between its endpoints. You can find the perimeter and area of figures such as rectangles and right triangles by finding the lengths of the line segments that make up their sides and then using the appropriate formula. Length times width. For area, 2 times the length plus 2 times the width for the perimeter. All right. Hopefully you are feeling like we have put in plenty of practice for finding distance between points that lie on the same horizontal or vertical line using absolute value or counting units. Hopefully you can use the coordinate plane to graph points and line segments, geometric shapes, and then you can use absolute value to find some distances between some of those points. We have now practiced extensively solving real-world mathematical problems using the coordinate plane, and we have used coordinates and absolute value to find the distance between points on the coordinate plane. So this concludes Module 3, Lesson 19, which means we have also concluded Module 3. So make sure you complete your problem set and your exit ticket. And great job for sticking it out through the module. And if you need assistance, make sure you talk to your teacher.